Hello everyone, my name is Dr. Mohammed Hamdan. I'm professor in mechanical engineering, and today I'm gonna give you an introduction to Xfoil. So if you're here, that means you know an Xfoil, and you can download the Xfoil from MIT website. You can go to Google and search for Xfoil, and first link here will be from MIT. You can go to this link and download the zip file and extract it. Once you do so, you will get the following. You will get this screen, this screen, and you can extract your file and you will get this. Once you click on it, you can run Xfoil using the execution file. So let's try run Xfoil. So run, and you will get the following screen. So this is the screen I get when I run Xfoil. Now, Xfoil allow you to solve for different airfoil 4 series and 5 series. So I can call the airfoil from here. So let's say NACA 2412. So I'm calling an airfoil called 2412, and you can see some information about the airfoil, like the thickness is the last 2 digits, which is 0.12 of the chord length, and it happened at x equal 0.3, and the camber is 2% of the chord, while it happened at 0.4, which is the second digit here, 0.4 from the chord. And we have here number of panel is 160. Now to operate in the on the airfoil and plot the pressure coefficient, we need to go to an option called Upper. So one thing that you need to know about is how to get help here. You can type question mark and you will get all the command that you can type here. Quit for exit. We're gonna go to the second one here, Upper, which is direct operating points. So we can go and type Upper. Now we'll go to Upper I, which means operation on inviscid flow. So let's say we have an inviscid flow and we would like to test this airfoil at angle of attack of 5. To test it at angle of attack of 5, we say A space 5. This will produce the following figure. So this figure is the pressure coefficient with the x distance. It shows you Cp as function of x, and you can see the y-axis is flipped. The negative is in upside, while the positive in the bottom side. The reason we did this so we can show that the Cp coefficient for the top surface of the airfoil is shown in the top side here, while the pressure coefficient in the bottom here is for the bottom side of the airfoil. You can see additional information here, the name of the airfoil, angle of attack, lift coefficient, moment coefficient, and profile drag. Now, if I want to test the value for example, viscous flow, all what I need is to type V here. This is mean viscous, and they ask you for Reynolds number. I can say, for example, let's test for 1 million. So now you can see Reynolds number is 1 million. Mach number, I can type M equal 0.2, which means at Mach number of 0.2. Now, if I want to replot this, I can say angle of attack here, A of 5. And now you see additional information. Mach number of 0.2, Reynolds number of 1 million, angle of attack, lift coefficient, moment coefficient, and drag coefficient. Lift to drag ratio. Now, if I want to test it at different angle of attack, I mean, I know as I increase angle of attack, I'm expecting lift coefficient will increase. So let's say angle of attack of 10. So you can see how it behave, but it say here not converge. Not converge because number of iteration is not enough. To have convergence, you can keep typing exclamation mark until you get convergence, or simply here, so you can see we got convergence. If you want to change number of iteration so you reach convergence, or you do not need to worry about convergence, you can type here iter, and this will ask you what number of iteration. Current iteration is 10, and I'm gonna change it to 500. So now if I want to say angle of attack of 10, I'll get this plot. Now if you notice, there is a yellow line here representing the boundary layer thickness in the top surface, and the boundary layer in the bottom is just stuck to the bottom surface. You can see that separation happened early here, or at this point. We can test the value of separation or the point of separation by running the command, the following command: A, angle of attack sequence from -2 to 14 with 1 degree increase. So if I do so, you can see it will produce the angle of, all these property for different angle of attack from -2 to 14. And you can see top X transition, which is moving from laminar, from where the flow will separate. While here, the bottom surface, you can see that once we increase angle of attack, there is no separation in the bottom plate here. While in the top surface, as we increase angle of attack, separation point move to the front or leading edge. Now, if we want to produce this table, you do not need to go and type it. There is a command that you can use, which is called, here, I wrote it somewhere here. So you can type the following command. You can type P, which is start polar accumulation, where you put the file name and then you rerun your command again. So we're gonna say P. So here I'll go to, I'll type P. It will ask me what file name you want. So I'm gonna call it test3.txt, and now it will start saving. And the dump file, I don't need it, so I just hit enter. Now I can run my command A sequence -2 to 14 and 1. You can use the up and down arrow so you can go through all the commands that you have did. So when I do this, it's saving all the run I had. So it's doing all this calculation. And saving these data, so I don't need to type it by hand. Once it finish, I can hit P if I want to stop accumulating data, and I can go to my file here and test3. So this is the file you will get. It has left drag, profile drag, CM, the location where the boundary layers separate. So all these information. Another thing we would like you to do is using polar plots. And polar plots is plotting something like this result here. So to do it, it's simple. All what you need is just type pp polar plot, and you will get the following graph. Yeah, we should have done this before polar accumulate. Oh, we did. So let's do it again. So here, test 4 txt, remove the dump, enabled. Now I can run the sequence. I was surprised that I didn't get the okay. So now we're running this command. Now I want to do the polar plot. I wasn't able to get the polar plot, so I'm gonna try the command once more. So here, polar plot, you can see it here, yes. So this show you the lift coefficient with the drag coefficient, the lift coefficient with angle of attack, and here where the separation start to happen. I hope this helped you to start with Xfoil. If you have any question or comment, please leave it in the comments and I'll be glad to answer it. Also, soon I will make another video to show you how you can manage or save an airfoil or create your own airfoil. Thank you for listening.